We are now talking about homework 11.4, problems 11 through 16. Before we begin to talk about arc length and circumference, it's important to talk about a few key vocabulary terms, such as arc measure, central angle, proportion, and intercepted arc. So arc length. The arc length of a given sector is going to be proportional to its central angle. And we're going to get into that when we answer questions 13 and 14. But for now, let's see if we can just fill in basic pieces of information about this circle, given what we're given. And we're given that this angle is 40 degrees, the radius is 4, I have centimeters, on your paper I think it says inches, and we're given that angle BDC is congruent to angle ADC. So let's fill in what we can fill in this circle. If angle BDA is 40, and these two angles are congruent, then we have that 40 plus, let's just call this x, (40) plus x equals 360. So that means that 40 plus 2x equals 360. Then 320 equals 2x, and so x equals 160. I won't be writing these down because I don't want you guys to just copy down everything I write. Hopefully you listen to this podcast and it helps you in your understanding. So we have BDC equaling 160. We're asked to find angle ACB, the arc measure of ACB. That's ACB. ACB is simply the whole circle minus 40, since our central angle is equal to its intercepted arc. So 360 minus 40 is just 320. For number 12, we're asked to find the arc measure for CA, and we just found that was 160. Number 13, you're asked to find the arc length of arc ACB. Now to find the arc length, since I said arc length is proportion of its central angle, we're going to first need to find the circumference and the central angles. We already found the central angle. For ACB, its central angle is 320. We'll write this down. So we have 320 degrees for our big central angle here. And we know that our intercepted arc must also be 320. We know that this must be 40. So we want to find the total circumference first, and then set up an equation using our proportions. The total circumference of the circle is going to be C equal to 2 pi r. So for us, that is equals 2 pi times 4, which is going to equal 8 pi. So our total circumference is equal to 8 pi, but we don't want our total circumference. It doesn't ask for that in this problem. We want the length of arc ACB, and ACB is 320 degrees. Our total circle is 360. So we can set up an equation with these proportions. 320 degrees over 360 degrees should equal the arc length which we wish to find. Let's just call that lowercase a. The arc length which we wish to find over our total circumference. Our total circumference is 8 pi. Now I could compute out 8 pi. It would be a nasty number though with a lot of decimals. So I'm just going to leave it as 8 pi, and it looks nice and neat here. And this equation makes sense because we have the proportion of arc measure over the total measure of degrees for the circle is equal to the proportion of arc length over the total length of the circle, or circumference. So if we want to solve this, all we need to do is multiply both sides of this equation by 8 pi, and we can undo the dividing by 8 pi since we wish to solve for the a. So my answer is just going to be my answer will simply be 360 divided by 320, which if we wish to reduce that is going to give us 160 over 180, which is going to give us 80 over 90, which is going to give us 40 over 45, which is going to give us 8 over 9. So we'll have 8 over 9 times 8 over 9 times 8 pi, and that will be equal to a. That's just going to give us 64 pi over 9 equal to a. Now this looks a lot nicer than if you would have calculated it, and instead of writing pi you would have written the full decimal expansion, which is like this: 64 pi equals divided by 9. That would be your answer if you just used a calculator. So there's our answer. Not too bad. Now we wish to find the length of arc CA. Well, CA, we just found ACB equals to 64 pi divided by 9. To find CA, CA is half of arc ACB. We can just take 64 divided by 9. I want to make this look nicer. 64 pi over 9. All we have to do is take this number 64 pi over 9 and divide it by 2 to get our measure for CA. And the same thing as dividing something by 2 is multiplying it by 1/2. So our final answer is just going to equal, if we want to cancel out our 2's in 64 and 2, then we're just going to get 32 pi. 32 pi over 9. I'm not going to write this out. Stop giving answers. So 32 pi over 9 for CA. For number 15, we're asked to find the measure of arc ABC. ABC. ABC is just going to be, ABC is simply going to be 40 plus whatever arc BC is. So we determined earlier that arc BC is 160. So 40 plus 160 is 200. So ABC is 200. Finally, we're asked to find the length of arc BAC. So we found the length of arc AC to equal 32 pi over 9. So we need to find the length of arc BA. Here we can set up another proportion. So I have 40 degrees. Oops. Just put this in there. I have 40 degrees over 360 degrees will equal, let's call this arc length of AB equal to just lowercase b, will equal lowercase b over total circumference, which is, we found up here, to be 8 pi. Again, we need to solve for b right here, so we multiply both sides of the equation by 8 pi, and we also reduce 40 over 360. 40 over 360 is kind of like 4 over 36, and that's going to equal 1 over 9. So your answer will just be 1 over 9 times 8 pi, which is 8 pi over 9. Well, that's not your final answer. I mean, that's the arc length of BA. So 8 pi over 9 is your arc length of BA. But we are asked to find the arc length of BAC, which is just going to equal 8 pi over 9 okay, 8 pi over 9 plus 64 pi over 9. Since 32 pi over 9. Because AC is half of ACB. And these have common denominators, so your final answer is simply going to be 40 pi over 9. And we know that because pi is kind of like a like term, and we're adding like terms. If I have 8 pi's plus 32 pi's, I'm going to get 40 pi's. And it's all going to be over 9. So I hope this helped with problems 11 through 16. Please bring any questions you have to class, and I'd love to talk about them.